All right, everybody. By now, you should have terminal access to your Linux environment. That's your local Linux environment. So that's on your PC, that's on your MacBook Pro. It's called local access. In the second half of this class, I'm hoping to be able to do some work on a Linux server. In the meantime, I'd like to get you familiarized with the file system in Linux. I'd like to work with you on basic navigation, and today I'd also like to discuss going through the man pages with you. In the second half of this class, I'd like to be able to take concepts that we've learned in the first half and apply them to a server situation. I'm not going to be planning too much ahead with the second half of this class yet, as there's some uncertainty as to what resources I'll have available. That said, I'd like to dive in. Since you all do have terminal access now, I'm going to launch the terminal here. So this is my MacBook Pro terminal. Everything I'm doing right now resides on my MacBook Pro. In a Linux environment or a Unix environment, we need to appreciate the fact that everything is a file, whether it's a directory, if it's a link, if it's something that you'd perceive to be a regular file, it's all a file. The screen that we're looking at right now is a file. And when we end a file, we do it with the end of file marker. So you'll see me exiting and working with that quite a bit. And I'm going to go into a little bit more detail on that in a few minutes. But for right now, let's understand that in Linux or Unix, which is referred to as a POSIX type operating system, that's POSIX. If you'd like to learn more about that, I suggest you do by go ahead and Googling it. Everything is a file. What you're looking at my screen here, when I'm typing like that right now, that all just went into a file. As I'm teaching this class, I'm going to make a lot of comments and type a lot of things on the screen. We're going to be working with shells. Right now, as you can see on the MacBook Pro, it says I'm using ZSH. That's the Z shell. That's a newer up-and-coming shell. MacBook Pros tend to be highly advanced when it comes to implementing newer technologies. In Linux, I believe the bash shell still is the standard. So if we type bash here, we get a different shell. And it says right here, the default interactive shell is now ZSH. To update your account to use ZSH, please run this for more information. So now you can see I'm using the bash shell. It looks completely different. It has a totally different prompt, which has a $sign there. This doesn't look very good. When we get into environment variables, I'm going to go into a little bit more detail on this. But for right now, we work with shells, and we have a different environment. So when I'm in a shell, this is the environment that I use within the terminal. I can have it's a session that I'm able to use, and I can run one session on top of another session, as you've seen right here. So when I'd logged in initially, this was the shell I was using right there. I typed in bash, which invoked another shell, and it gave me a different shell. There's also the sh shell, which I don't know if it exists here, so let's find out. It does. So this is yet again another shell. And if I want to go back to bash again, I can do that and go to the bash shell. So now I keep invoking all of these different shells, and I can do all this different work. I can do a listing here, what have you. But I have all these different environments running on top of each other. The exit command is one of the first commands I will show you with shells. If we type exit, it will take you out of your existing shell and put you into a previous shell. if no previous shell exists, it will take you out of the system completely. So I'll do that right now. I will type EXIT, which, like I said, since everything is a file, including these shells, I type exit, and it takes me back to the previous shell. Now if I type exit again, it yet again takes me to the shell I had before that. Now I'm going to change what I type a little bit. I'm going to hit Control D, which is the end of file marker. And since everything is a file in Linux, it should end the file, which it does. When I hit Control D, it throws the end of file marker there. It ends the file. So now I'm in my original shell. If I hit Control D now, there's no other shell beneath this one. So it's going to take me out of the terminal completely. When you do this on a Windows machine with Ubuntu, it's going to just take the window away altogether. So now I'm going to open it back up again. So now that we understand that everything is a file, I've clarified that pretty well. I want to talk about comments in Linux. The pound sign is usually a comment. As you can see in the Z shell, it's not, however. But we're going to be teaching bash in this class. So I'll go to the bash shell where I put in a pound, and it indeed is a comment. So there's a classic example of how the shells are different. I'm really glad that happened, actually. When I'm teaching this class, I might want to put something in reference on the screen. If I just type check this out here or something like that, I want to put something on the screen so you can read it. If I hit enter here, it's going to give me an error. I don't want to deal with that error. It doesn't look good on the screen when I do that and when I present it to you. So if I simply turn that into a comment, I don't get the error. So a lot of times when I write here, I will put a pound sign in just to make it a comment. When you're writing scripts, which we'll do later in this class, comments are really helpful. So that being said, let's move on and discuss the fact that Linux is an extensionless system. If you've been using a MacBook Pro your whole life, this doesn't mean anything to you. However, if you've worked in Windows environments, you'll notice that a lot of files will end in .exe. They might end in .txt. They might end in BAT. So they have all these different extensions here that get used in that actually mean something, that actually will invoke a specific response in a Windows environment. If you work at the terminal in Linux, these extensions don't mean anything. We can set these up and give them colors and give them other attributes, but by default, these extensions mean nothing to Linux, and we should treat it as such. Just as in everything else, we have a path. The path in Linux looks much different than the path in Windows. In Windows, we have drive letters that represent different file locations. There can be more than one root on a Windows machine based on whatever drive you're on. In Linux, everything is mounted off the root. So when we look at the file structure, it might look something similar to this right here. This is a MacBook, so it's a little bit different. As we move on, hopefully towards the second half of this class, we're going to put meaning to these different directories, and we're going to work in a real systems environment. Until then, we're going to discuss and work locally. Linux is a case-sensitive environment. So everything in Linux has case sensitivity. This is not the case in Windows. So if I look here, I can see I've got all these different files here, like this file here, greppy, for example. If I wanted to do an ls, and here I just did an ls. Let's talk about that. So all ls does is lists a directory. If you're familiar with MS-DOS, it's going to be dir. So when we list a directory, we get information. If I type ls and I want to see files, and I want to see the file greppy.txt, I can type ls greppy.txt and it will display the file. If I type in ls greppy with a capital G, for example, there is no capital G here. It's not going to find this. It's going to give me an error. So it doesn't matter where the G goes. It can't be all caps. It has to be exactly case sensitive as we move around. So that's something that's really, really important to understand. If I am not sure how to spell something, Linux makes it very helpful. So if I type GR and I hit the tab key now, it's going to fill out as much as it can. So you can see we have several different files that could match this scenario here. So let's say we want greppy.txt. So we can do a .t and then hit tab again. It'll help us out. Using the tab key is really, really nice. It really helps you prevent typing errors. If I wanted to type in the directory for sites, I could just type a capital S and hit the tab key and it'll populate the whole thing for me. So that's really nice, and this works because there is only one identity that starts with the capital S. If I were to do a small s, there is nothing here that starts with a small s, so I hit tab there, it's not going to do anything at all for me. Spaces and names are perfectly valid in Linux, but they're somewhat difficult to work with and understand. So one thing we can do is we can escape sequence, or we can do this by putting it in quotes. So let's create a directory right now, for example, okay? So let's do this. Let's learn the make directory command real quick here. So we type mkdir. We're going to put this in single quotes. We're going to call this week 1. We're going to close the quotes. So if we type it in and we put it in quotes like that, we can see now that we get week 1. That's a file. So now, however, if I want to type ls and I type week 1 and hit enter, what am I going to get? I'm going to get nothing but errors here. So I'd have to do an ls. I'd have to either enclose that in quotes like that to get my week 1, which doesn't find anything, or I would have to list it using what's called an escape sequence. So here I can actually cheat, and since there's only one W, I can type it with the W and hit tab. And here it gives me the escape sequence. With this escape sequence, this backslash here, followed by the next character, it says, hey, take this literally, it's okay. So we have to warn the system that there's a space coming up, and that's how we do that. So, and the / just indicates that it's a directory. So we could also just go like that. So we see that it doesn't give us anything there. We go like this, it doesn't give us anything there. Well, the reason is because there's no files in there. It didn't give us an error either. So those are the two ways that we can create directories, and work with files and spacing. Hopefully that makes sense to you. If not, please feel free to contact me, and we can go through this a little bit more clearly. There's also a ton of internet resources that are useful with this. So now let's talk about hidden files and directories. If I type an ls right there, first of all, you don't see anything hidden, but there is hidden stuff here because I am using the bash shell, and I know that bash hides a lot of stuff. In Windows, we have file attributes that we use to hide files. In Linux, anything that begins with a period is hidden, including parent and current directories. Going back to ls, which is list directory, so we can type ls, which just gives you a standard listing, or an ls-l, which gives you a detailed listing. I'm going to go into all of these different ls items and all these columns later, so don't worry about that. I do this standard ls right there with the -l. I get a listing. If I do an ls-a, you can see these files that begin with these periods here. These files are hidden. You have to put the -a attribute flag in to see them. Most people aren't going to do that. So you could do an ls-al, -al, and get these hidden files to display. Or you could do a -la. The order isn't going to matter with the parameters, but I want to show you that you need to specify the A to show the hidden files. This is really important so far, and I hope that you have a good understanding of how case sensitivity is important, how to handle spacing, and I'm also concerned that we understand that everything, whether it's a directory or not, is a file. So while we're here real quick, in this very first position here, that D tells us it's a directory. This dash right here tells us it's a regular file. And if there was an L right here, that would mean it was a link similar to a shortcut in Windows. However, everything is a file. Now let's talk about where we are and how to get around. So basic navigation. So where are we? PWD is what we type here. That does not stand for password. That's what it looks like it stands for. However, that's not what it stands for. That stands for present working directory. So I type that. That tells me where I am in the system, and I'm under /users, which you'll notice is capitalized. So we'll get back to that. So what's in our current location? That's the next thing we want to ask. So we've already been talking about our ls command a little bit. So we'll do the ls. We can see that that's there. We want to see some detail. We do an ls-l. We've already gone through that a little bit. So the format for this, and now I'm going to use one of our pound signs, is going to be ls. You can have any options or parameters you'd like to pass in, which would be -l. And then the location. You can leave this blank and it'll default to the present working directory or the current working directory, which is the hidden file simply period. So you could type that. It's going to look for something. Actually, that's wrong, actually. No, it's not. PWD. So there's nothing in here. Don't ask me why that happened. I must have had a little typo or something there. But do the ls-l, which is the -l is the parameters, the ls is the command, and if you want to have the file or the location, that would go next. So week 1, we're not going to get anything under week 1 because we haven't placed any files there yet. So now I want to go into absolute and relative paths. So there's two types of paths. There's the path that we can go to from where we are currently, and there's the path from the root. For example, when we type in pwd, that tells me that I'm already under users Glenn Sheneman. If I wanted to go into week 1, I could do a change directory and go into week 1. Okay, now I type pwd again, you can see I'm in week 1. So when I was already in this directory right there, I changed to week 1. Now I'm in the week 1 directory. I just typed cd week 1 because I did it from my relative position, which is right here. I could have also typed the absolute position, which would have been something like this. That would have been the absolute path. It's going to put me in the exact same place, as you can see. So here I change directories using a relative path. Here I change directories from the root, from the start of the system, and used an absolute path. As we go into the directory structures of Linux and Unix, this is going to become more clear, but for now this is an important concept for us to grasp and understand. Let's talk about a couple different concepts with paths here. Let me go to a completely different directory here. So now I'm in the etc directory. I verified that using pwd. Every user, or almost every user in Linux, has what's known as a home directory. This is their starting point in the system. Once we get onto a server, I'm going to hopefully have us all have users. We're going to have our own home directories. It's going to be really nice, and we'll work as a collective, as a class, like we would in a real business setting. So that being said, if I wanted to simply type cd and hit enter, it's going to assume the tilde. Actually, I'm going to type the tilde first. So I type the tilde, it's going to put me back into my designated home directory. If you're using Ubuntu right now, it's going to say /home/ and then whatever your user ID is. On a MacBook, it's under capital users. So I type in cd with the tilde, it puts me into my home. So now let me go someplace else, totally different directory. Now if I simply just type cd, the tilde is going to be assumed. It wasn't always like that, but it has been for some time now. So now let's talk about your current directory. That is represented by a hidden file known as the dot. So if I type cd and then type a dot, I'm still in my same directory. If I type in cd ... it's going to take me back to my parent directory or the previous directory. So now if I type pwd, I'm under /users. So can we get fancy with that? Yes, we can. So let's do this. Let's go back to my present working directory. Okay. Now I'm in my present working directory is now also my home directory. So if I do a pwd, I am under this. Let's go under desktop. And some of you might not have the permission to do this on a MacBook. That's okay. Actually, you know what? That's not okay. Let's go ahead and make a temp directory. mkdir temp. Okay, and now cd temp. So now we're in the temp directory. Let's go back one level. So I'm going to do a cd ... to go back to where I was, my parent directory. Now I'm going to mkdir temp
2. Now I'm going to change back into the temp directory. So now let's get from here, let's first use a relative path to get to temp2 from temp. So here I am in temp. So I would type cd ... to go back to my parent directory, then temp2 to put me into the temp2 directory. So I went back to the parent directory, then forward to temp2. So now you can see that's one way, using a relative path, that I got the temp2. So this is great here, and it sounds like a really good way to do things. Oh, this is a lot less typing than an absolute path. But now let's go back a couple parent levels. Okay, so now I'm back in users. So I've gone back to the parent of the parent. So that's 2 levels. So that's parent of the parent. Okay, so now let's try and issue that same command. So now if I try to go to temp2, this relative path isn't any good anymore, and it's going to give me an error. Whereas if I would have used an absolute path, I'd get there every time, no matter where I was. So there's advantages to both types of paths, but relative paths won't work every time. Sometimes this is great and it keeps things simple. Sometimes it's not. So at this point, we've taught you how to make directories, how to change directories. Removing directories is a little bit more difficult, so we're going to work on that a little bit later on. For now, I'd like to move on to one more thing. We've talked about the man page. You've probably seen me type ls-ltr a couple times. Let me go back to where there actually is something. You've seen me do an ls-ltr a couple times. Let's try an ls-ltra and get the hidden stuff with it. So now, what does that mean? Well, that's going to be your first assignment, I think. It's going to be, what can we do with LTR, with ls-ltr and ls-ltra? For this, we're going to learn about man pages. When Linux was created, we used man pages instead of help pages. Man was short for manual. ls was short for listing. cd is short for change directories. It was common and useful for commands to be short and quick and easy to type. Therefore, you'll find that Linux is somewhat cryptic if you're not used to it. So let's type man. So man stands for manual. So let's get the manual for the ls page. And here it is. So it tells you what ls does. It gives you the synopsis. It gives you a nice description. And it's going to give you all the different parameters that you can type along with it. And again, these are case sensitive just like anything else. So you'll see the uppercase and lowercase version of these. So you see me doing an L, for example. There's the L. And you'll see the T and the R's. So you can look around a man page like this. Let's say you want to do a man page on a specific word or something you might not know. So let's say you do a -K. A -K will give you the ability to search on a keyword. So let's say you want to do a search for the word run. So it's going to give you all these different commands that have run included with it, all these different help topics where run is part of it. So it is indexed, it is searchable. So how do we learn more about man? I don't know. Maybe type man. So now you got the man page for man.
and that's useful, and you can get a bunch of different commands to help you with that. So the man pages are for help, and they're very useful. I've given you a lot at this point, so please try and digest this. At this point, I'm going to hit Control D, and here, just for fun, I'm going to type exit. And that's our lesson for today. Thank you.